Kia ora Year 12. It would help if you've watched video 1 on exponentials and logs first. I'm going to follow the same pattern in here. There are 3 integrals here, and 2 of them need integration by parts, and 1 can be done either just by looking or with substitution. So have a go at them first, and then I'm going to go through each of them. Okay, so let's look at this first one and decide if it's going to be a tricky one or a reasonably easy one. So we can see in here that we've got the log of x here, natural log of x, and here we've got its derivative. So that's always a promising pattern to have. So some of you are going to spot that this is going to be a straightforward one. And this one here, there's nothing really to work with except for the natural log of x. So it's not going to be a backwards chain rule, right? So we know how to differentiate the log of x. We get 1 over x, but we don't yet know how to integrate it. So this one is probably going to be integration by parts, except that we don't have a product. So we have to somehow get one. And this last one definitely looks like an integration by parts candidate. I've got a product, I've got the natural log of x here, and I've got something here which isn't its derivative. Okay, so let's start with this first one. And we can do it using substitution, or we can do it just by doing backwards chain rule. So I'm going to do it by looking first. Let's try this. If we've got the natural log of x and we square it, let's think about what would happen if we differentiated that. So if we had y is equal to the natural log of x squared, then dy by dx by the chain rule would be 2 times the log of x to the power of 1 times the derivative of the inside function. And you can see that that's almost exactly what we've got. So all we need to do to integrate this is to go the log of x squared times 1/2 plus c. So that's great once you're at a level where you can spot that straight away. Most of you probably will be doing that question by inspection. But what if you're not? Well, we can look at it and we can use u substitution. So we can say let u equal the natural log of x, du by dx is equal to 1 over x. So separating the du and the dx gives me du is equal to 1 over x dx. So let's have a look at the integral. We've got 1 over x times the log of x integrated with respect to x. So here we've got du equals 1 over x dx, and here we've got the 1 over x dx. So we can rewrite this as u du. And that integrates to give me 1/2 u squared plus c, which is 1/2 of log x squared plus c, which is what we got by inspection. Okay, that's the first one done. Now let's look at these next two that are kind of classic integration by parts problems. And we've done them in class before, but it's worth doing them again. Okay, so if we've got the integral of the log of x dx, to do integration by parts we need to have the product. So we're going to have 1 times the natural log of x dx. And when we're integrating by parts, we have one bit that we integrate and one bit that we either leave or differentiate. Now we can't integrate this, right? That's the whole point of the problem. So this is the bit that I'm first going to leave and then I'm going to differentiate. This 1 I'm going to integrate both times. So let's see how it goes. Well, we've got 1 times the log of x dx is equal to x, integrating the 1, times the log of x, minus, integrating the 1 gives us x, but this time we differentiate the log of x, and we get 1 over x dx. And you can see that that's simplifying down really well. We get x log x minus the integral of just 1 times dx, which gives us x log x minus x plus c. Alright, let's have a look now. And we can differentiate that back, by the way, to check that it's right, and you might want to do that for some nice product rule practice on that one there. But I'm not going to do that in the video. So that's question 4 and question 5. Now, what about the last one? Well, we've got x times log of x dx. So that too is going to be integration by parts. I'm going to leave this or differentiate it, and I'm going to integrate this both times. So we get a half x squared log of x minus this integral, half x squared times 1 over x dx. That gives me this. Now I've done indefinite integrals in all of these videos because it's faster, but just make sure that you can do it with limits up here as well. If you do that, it will obviously affect this bit first and then this bit here. So here we've got minus 1/2 times a half x squared plus c. That gives us a final answer of a half x squared log x minus a quarter x squared plus c. So we could check, I'm going to check that one just because this video is quite short. Let's just have a go and see if we get back to the right thing. So factorising this, I'm going to get 1/4 x squared times, what am I going to do here, 2 log x minus 1. That's probably going to be the fastest way to practice my differentiation. So let's do some product rule on that and make sure we get back to the integral we want. So dy by dx is going to equal 1/4 x squared here times the derivative of the inside function. Sorry, times, so this is u and this is v. So this is the first times the derivative of the second, which is 2 over x, plus the second times the derivative of this, which is going to be 2/4 of x. That gives me x over 2 plus 2 log x minus 1 times x over 2, which gets me back to x over 2 plus 2x over 2 log x minus x over 2, which gives us x log x, which is what we needed. So notice that what's happened there is, of course, the plus c is the constant, and so when I differentiate, it leaves no derivative. Thanks for watching. The third video is going to have 3 slightly harder ones, which are also going to be exponentials, but they take a little bit more thinking about. I'll do that one shortly.